Hello everyone, let's start the class. Let's continue our yesterday's topic. So I think yesterday what we are discussing was valency. Valency is what we were discussing. Okay, so we have talked about different kind of valencies of different groups. Okay, and I told you that in case of S or in case of S block there is two type of valency, either 1 and 2. And in case of P, I told you different valencies are there. And how we get to know the valency? That is number of electrons that need to be either filled, or that is I can say gained or loosed in order to complete the octet or duplet of the respective element. Okay, this kind of things were there. And you know that hydrogen, helium, lithium, these kind of things go for duplet, beryllium also. Okay, these kind of things try to go for duplet by losing the electrons. And more elements like we say let us say oxygen, fluorine, sodium, and apart from this calcium, these all try to complete their octet. Similar to that, I told you some like sodium and magnesium, these guys are losing the electrons. And apart from that, some guys like oxygen and fluorine were gaining the electrons. I think that was what we have read yesterday. Okay, yesterday we have completed these kind of things. Okay, till here I don't think so anybody is having any doubt. Okay, so anybody if want to ask something? No. Okay. Okay, let's continue. Yesterday I told you about there is one guy named carbon, and what was its atomic number? It was 6, and configuration was 1s2, 2s2 and 2p2. So what was the case is, it can lose 2 electrons, it has 4 electrons in its outermost shell. So to make 8, it has to either lose 4 or it has to gain 4. Okay, both cases it can do. Okay, both are possibility. It can either gain 4 or it can lose 4, both are the possibilities. So its valency will be considered 4. One more thing is there, instead of gaining and losing, all of you know that it tend to share the electrons. It will always try to share the electron instead of losing or gaining. So usually it will share electron and form covalent bond, but that is a different story. That someday else we will read when chemical bonding we will be reading. Okay, so this is that. And one more thing is hydrogen. Hydrogen, you know, atomic number is 1 and configuration is 1s1. Now if he has to complete its duplet, it can gain 1 electron. It can gain 1 electron and it will be 1s2, that is a helium like configuration. But one more possibility is there, if it lose 1 electron. See, if it lose 1 electron, what it will become? It will become 1s0, only nucleus, no electrons, that kind of thing. That is also very, very stable, that is also possible. And that kind of form is known as H plus. Hydrogen with 1 electron lose is known as H plus, or we call it proton. Why we call it proton? Because only nucleus is left and nucleus of hydrogen contains 1 proton only, no neutrons, only 1 proton. That's why it is also known as proton. So that is the thing. This is all about hydrogen that we have to know. Okay, till here anybody has any doubt? So hydrogen can lose 1, hydrogen can gain 1, both it can do. Carbon can lose 4, carbon can gain 4. Is it okay? Carbon's valency always 4, hydrogen's valency always 1. Is it okay? That is the valency. Anybody has any kind of doubt, you can ask. Can you explain last part? Very good. Okay, let me explain once again. Let's explain it on next slide. Yeah. See, hydrogen has Z is equal to 1. Its configuration is 1s1. It can do two things. One, it can gain 1 electron. gain one electron, and what it will form? 1s2 kind of configuration, and it is helium like configuration. Okay, so it is a noble gas configuration. Apart from that, it can also lose one electron. Losing one electron is also possible, and what it will become? 1s0. that means there is no electrons at all. No electrons. No electrons means only nucleus. Only nucleus of hydrogen is there. Only nucleus is there. Say yes or no? Only nucleus is there. Okay, so only nucleus, and hydrogen nucleus contains one proton only, nothing else, nothing other than that, one proton only, and that's why it is known as proton. Or because hydrogen has loose electrons, that have one electron loosed, that's why it is known as H plus. So we can write it H plus, or we can write it proton. Its name can be proton only, we just call it proton, or H plus means the same thing. Similar to that, if you move here, tell me what we can say. This hydrogen after gaining one electron, what we will write? Tell me. D-deuterium, that is a different thing, that is the isotope of hydrogen. After gaining of one electron, what will hydrogen be called? Tell me. Hydride, very good. Hydride, H minus, very good. H minus, very good. Hydride, very good. H minus, very good. H minus, or hydride. Both we can call it H minus or hydride. H minus, very good. That's it. That's it. That's all about hydrogen. And if somebody asks you what is the valency of hydrogen, always one. Always one you have to say. Is it okay? Always one. Now let us move. Now let us move to the next topic, that is position of elements in periodic table. That is a very important topic that will help you too much. That will help you in determining of properties also later. Okay, position of elements in periodic table, that if somebody give you a random element along with its atomic number, then you have to decide, you have to know how to decide that in which group or which period or which part of the periodic table it will lie. Is it okay? This is what we are going to learn here. Okay, let's think about this. First of all, how to determine block. I think this all of you know. This all of you know. In whatever orbital last electron go, in whatever orbital last electron go, to that kind of block it will be related to. Okay, it will lie in that block. For example, if last electron is going in S, the element is said to be of S block. If P, then P block, then if D, then D block, F, then F block. All of this we have already done. Okay, block determination we have already done. Let us think about an example. Think about, let us say, what example? Let us say I am taking gallium. Okay, gallium is 31. Can anybody tell me what is the electronic configuration of gallium 31? Write the electronic configuration of gallium 31 first in the comment box. Gallium 31. Electronic configuration I want. 4s2 4p1. Very good. 4s2 4p1. Very good. Monkey D. Luffy. Very good. Very good. Ritika Kaushik. Very good. We don't write this 288. Now you are not Chinna baby. Behave like elder students. Don't behave like chinna babies. And don't write that 288. Very good. 4s2, 4p2. How? Okay, let us start. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 and 4s, sorry, not 4s, 4p1. That is the thing. And you know, up to here what it is? Argon it is. So you can write argon 18, 4s2, 3d10, 4p1. So where last electron is going? In which type of orbital last electron is going? In which type of orbital? Right? Right first, which orbital? SPD or F? SPD or F? Where? P. Very good. P. Very good. P. Very good. So in last electron is going into p orbital. That's why it will be considered as a member of p block. So block determination is easy. We have already done this. The important thing that we have to do today in today's lecture is to determine groups and period. That is determination of group and determination of period. So first I am writing determination of period, and second one is determination of group. So determination of period, first let us do this one. Determination of period, that is very easy. Okay, what you have to do is, again you have to write the electronic configuration. Every time whenever you have to determine the position in periodic table, you have to first write electronic configuration. Again take our last example, gallium, that is argon 18, then 4s2, 3d10, 4p1. Now tell me, what is the highest shell that is filled? Shell means, you know, shell means principal quantum number. This one, shell, highest shell that is filled. Which highest shell is filled? Tell me. Right? Write fast. Which highest shell is filled? Highest shell, fourth. Highest shell is fourth. D is subshell. D is subshell. Sanjana, D is subshell. So what we have to know? Yeah, fourth. Shell is fourth. F is also subshell. 4, very good. No, see, 4 is there, higher than 3. N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4. Higher shell we are talking about. So highest is fourth. So its period will be, obviously its period will be fourth. That's it. Its period will be fourth. Okay. Apart from that, let us think about calcium. Tell me, calcium, Z is equal to 20. Tell me, what will be its period? Tell me. Second, 44. What you are writing? Okay, again 1s2, 2s2, 2p6, 3s2, 3p. 6 4s2. That's it, 4s2. That is the configuration. So who is the highest filled shell? Fourth is the highest filled shell, and that's it. You can determine by this that fourth shell is highest. That means its period will be fourth. Its period will be fourth. That's it. Now think about iodine 54. Iodine 54. Write the electronic configuration iodine 54 and tell me which period it belongs to. Iodine 54. Iodine. Write the electronic configuration of iodine. Write it fast. Five. How you get to know? Tell me the configuration. It is krypton 36, then I think 5s2 4d10 and then 5p5. That's it. Not like that. That's it. Okay. Or we can write complete also. If you want, we can write complete also. No problem is there. One s2, 2s2, 2p6, 3s2, then 3p6, then 4s2, 3d10, then 4p6, then 5s2, then 4d10, and then 5p5. I think that's it. 2 to 4, 6, 10, 10 to 12, 12 and 6, 18, 20, 30, 36, 38, 48 and 53 it is. How it is coming 53? Let me check it. Something we are missing? No, I think. Okay, that's it. Iodine 53. Oh, yeah. We have missed. Iodine is 53, no? That's why. Misprint in the data. Misprint in the data. Okay. Misprint in the data. 53. Okay. Iodine is 53. That's it. Okay. That is the electronic configuration. That is okay. Okay. Yeah, that is correct. That is misprint in the data. Okay. So that is all about periods, I think. Very easily you can tell. Okay. And if you think about one more, let us take one more example, and it will be, let us say, try this. Zinc 30. Try. Iodine atomic number 53. Yeah, that was misprint in the data. Okay, leave it. Zinc 30. Zinc 30. Zinc 30. fourth, very good. Fourth, very good. Now it is argon 18, then 4s2 3d 10. That's it. Highest is fourth one, and that's why period number is fourth. Okay, period is fourth period. That's it. Okay, that's it. Think lanthanum 57. Right for this one. Lanthanum 57. Lanthanum 57. Lanthanum 57. 6 5 6 5 5 5. Very good. 6 5 6 5. Very good. Let us write 1s2 2s2 2p6 3s2 3p6 4s2 3d10, then 4p6 5s2, then 5, sorry, mistake, then it is 4d10, then 5p6, then it will be 6s2 and 5d1. Check whether it is okay or not. Some mistake is not there. 2 4 4 and 6 10 12 18 20 30 36 38 48 54 50 56 57. Yeah, that's it. So which is the, I think, up to from here to here, it is xenon. So I can write it xenon 54 6s2 5d1. So which is the highest period? I think this is period number 6. That is the thing, period number 6. Okay, period number 6 is the thing. Okay, that's it. 6 is the answer, right? Have you got it? Say yes or no. Period number 6. Period number 6 is the answer. Okay. Now let us move to the next topic, and our next topic is determination of groups. That is very, very important. Determination of groups. Whenever you have to determine the group of an element, what first thing you have to do is, first thing and foremost important thing, that is to determine the block. That is very, very important, to determine the block. On the basis of block only you can tell that what group it lies. Okay, first of all you have to determine the block. Okay, now let us take an example. Anybody, if somebody is asking something, what happened to the previous sir? Okay, let me tell you what happened to the previous sir. Actually, previous sir got married, so you can think. Now he is already in a big trap. Okay, bigger trap than this one. Okay, so he has like put himself into a bigger trap. Okay, let us move. Determination of the block. First we have to do determination of the block. Let us think Mg, atomic number 12. Tell me the block. Tell me the block. Tell me the block. S block. Very good. S block. Very good. S block. Very good. S block. S block. Very good. Everyone, S block. Very good. So it is S block. Whenever some S block element is there, how you have to determine the group number? So group number is equal to number of electrons in outermost s orbitals, or we can say outermost s subshell. Okay, whatever electrons are there in outermost s, what I have written, outermost s, please be sure about this, what I am writing, outermost s I am talking about only. Okay, outermost s, that will be its number of group. So you can write the electronic configuration, all of you know, 1s2, 2s2, 2p6, 3s2, that's it. 1s2, 2s2, 2p6, 3s2. Okay, so which is the outermost s? Tell me, is 1s the outermost s? Tell me, 1s outermost s? Tell me, yes or no? Is 1s outermost s? No sir, very good, no. So which one is the outermost s? Tell me, 3s, yeah, 3s, 3s. So which is the outermost s? 3s is the outermost s, and group number will be equal to number of electrons in this s. How many electrons are there in this outermost s, that is 3s? How many electrons are there? Tell me. How many electrons are there in this 3s? Tell me, 3s, how many electrons? 2, 2, 2, very good, 2 electrons are there. So what will be the group number? Obviously 2, obviously 2. Is it okay? Anybody who has any kind of doubt, please ask. Anybody having any kind of doubt, please ask. Anybody who has any kind of doubt, please ask. I don't think so, no doubts. Okay, let's write, find the group number for cesium 55. Cesium 55. Okay, please write the group number for cesium 55. What is the group number? Tell me. Write the configuration. First determine the block, then write the configuration, and then very easily you can tell. 2. Hey, why 2? Why you are writing 2? First tell me the block. Which block it is? Very good. Zombie Slayer, very good. 1, 1, very good. 1, very good. 1, very good. 1, very good. S block, very good. Okay. So what we can write? Cesium is xenon 54 6s1. That is the configuration, and you know it belongs to S block, and S block means outermost S, whatever electrons are there, that is the group number. So if I write group number, it will be equal to 1, because outermost S contains 1 electron. That is the thing, outermost S contains 1 electron. Till here, anybody has any kind of doubt, you can ask. Ask me if there is some doubt. Ask me. Ask me if there is some doubt. Very good. See this, ask me the doubts. No doubt, very good. No doubt, very good. No doubt, very good. Very good. Let's move. Let's move to the determination of group for D block elements. If D block is there, okay, think about, let us say manganese is there, Mn, okay, Z is equal to 25, write its configuration, it is Ar18 4s2 3d 5, that is the configuration, and last electron is going into D orbital, so it is a D block element. Now in case of D block elements, what you have to do, number of group is equal to n minus 1 d, or I should write electrons in n minus 1 d plus electrons in ns. Okay, that is outermost s and penultimate d. Okay, ns and n minus 1 d. Now tell me, in this case what it will be? In this case, tell me, in this case what we can say? In this case, how many d and how many s electrons are there? Speak. Speak everyone. Group 7. Group 7. Very good. Group 7. 6. How 6? 5 are there in D and 2 are there in S. 5 plus 2, it is 7 already. 7. Okay, 7. So electrons in n minus 1 D is 5 plus electrons in ns are 2. So 5 plus 2, 7. So manganese belongs to 7th group. Just tell me what about chromium 24. Chromium 24 and copper 29. This also you have to tell. Chromium 24 and copper 29. Tell me. Chromium 24 and copper 29. Chromium 24 and copper 29. Okay. Please write answer along with that. Chromium this. Yeah, like this. Chromium this and copper this. Chromium 6. Very good. Chromium 6. Very good. Chromium 6. Very good. Those who are saying 9 for copper, check your electronic configuration. Check your electronic configuration. Copper 6. Very good. Sorry, chromium 6. Very good. Copper is not 6. Chromium 6. Very good. Copper 11. Very good. Copper 11. Very good. Copper 11. Yeah, let us see. See, chromium is what? Xenon. Sorry, not xenon. Argon 18, 4s1, 3d5. You know exceptional configuration, I told you. Exceptional configuration, this is similar to that. Argon 18, 4s1, 3d10. Tell me, number of group is electrons in n minus 1 d, that is 5, plus electrons in ns 1, that is 6. Okay, here also group number is equal to electrons in n minus 1 d 10 plus electrons in ns 1, that is 11. Here 6 and here 11. How many got the correct answer? How many got the correct answer? How many got the correct answer? Me. Yes, I. Very good. Very good. Very good. Very good. Very good. Very good. And those who are getting copper 9, have you got your mistake? What was the mistake? Have you got your mistake, copper 9 guys? Any copper 9 guys? Please tell me whether you got your mistake or not. What was the mistake? You got it or not? Very good. Very good. Very good. Mimi, very good. Very good. Okay. Let us move to third one, that is p block elements. P block elements. Okay. For p block elements, let us think about one, that is aluminium. Okay. Z is equal to 13. First of all, you have to know that whether it is a p block element or not. Okay. So it is 1s2, 2s2, 2p6, 3s2 3p3. Okay, that's it. 3s2 3p3. Okay, so think about this, how you have to find its group number. Just what you have to do is electrons in 3s plus 3p, that is group number electrons in ns plus np and plus and plus 8. This is the formula. Or there is one more formula, that is electrons in np plus 10. Directly you can use this, electrons in np plus 10. Okay, now tell me, what about this aluminium? Electrons in ns plus np, electrons in ns plus np, that is 3s plus 3p, 2 plus 3 and plus 8 we have to do, that will come 15. 8 plus 2, oh not 15, actually 13 it is. That is 13. Okay, 13 group. So aluminium belongs to 13 group. Yeah, everybody correct. And you can use this one, this formula also. Electrons in np plus 10. Electrons in np is 3 plus 10. That is also 13. Okay, that is also 13. Tell me for chlorine 17 and selenium 34, two of them. Yeah, chlorine 17 and selenium 34. Start. Chlorine 17 group, chlorine 17 group. Okay, chlorine 17 group, selenium 16, 17 16, 15 also. Okay, 17 16, selenium 16, selenium 16, very good. 15, Venkateshwar, please check, please check. 34, very good. See, first of all check whether they are p block or not. 1s2, 2s2, 2p6, 3s2, 3p, 5. So s and p total. So group number is 2 plus 5 plus 8, that is is it okay? Wait, something we have missed, I think. That is okay. See, we have made a small mistake. See, we have made a small mistake. Please correct this. Okay, it will be 3p, not 3p3. This should be, there is a small thing that we have missed. First of all, aluminium configuration we are doing wrong. Okay, so here in formula 10 and here 12. Please update this formula. Okay, update this formula. Okay, so 2 plus 3 plus 10, it will be 13. Sorry, 2 plus 3 plus 10, it will be so it will be 2 plus 1 plus 10. So it will be 2 plus 1 plus 10 or 1 plus 12, that is 13. Okay, that is a slight thing that we have missed. Eraser also. Here also you have to write 2 plus 5 plus 10, that is 17, or you have to write that is 5 plus 12, that is equal to 17. Yeah, that's it. That's it. Okay, that's it. Configuration wrong, we have written mistakenly. Okay, so it should be 10 and it should be 12. Please correct the formula. Please correct the formula. This one is 13. Okay, 2 plus 1 plus 10 or 1 plus 12, that is ns plus np plus 10 or np plus 12, that is the thing. Okay, and similar here, ns plus np plus 10, that is 17, or np plus 12, that is 17. Now you can go for selenium 34. Now you can go for selenium 34. Yeah, it will be 1s2, 2s2, 2p6, 3s2, then 3p6, then 4s2, 3d10, and then it will be 4p4. Okay, 2 to 4, 6, 10, 10 to 12, 12 and 6, 18, 20, 30, 34. Yeah, that's it. So it is a p block element. Again, we can either count 4s and 4p. So group will be equal to 4s and 4p, 2 plus 4 plus 10, that is equal to 16, or we can directly take 4p, that is 4 plus 12, that is also equal to 16. Yeah, that is the thing. Okay, that is the thing. 16, that is the thing. Got it? I think you got it. I think you got it. Okay, slight update in the formula. Please be sure about this update. Okay, please correct this. 10 and 12, this should be 10 and 12. Okay, that's it. Now last and the easiest, F block. Whenever you find some F block element, always consider as group 3. All of the F blocks lie in group 3. All of the F block elements will lie in group 3. That is the thing. All of the F block elements will lie in group 3. Yeah, that's it. Now let us do some general questions. Okay, so let us write one by one. Fluorine 9. Okay, now random questions I am giving. Okay, then comes second, that is potassium 19. Okay, third one, iron 26. Okay, similar to that, silicon 14. Okay, try to do this, then I will give you some more. These are easy. These are very, very easy. Fluorine is fluorine is 17, potassium 1, iron 26. 26? Only 18 groups are there in the periodic table. How 26? Silicon 4. How? Both wrong. Okay. Iron 8. Okay. Silicon 14. Yeah, Sanjana, right. All right. Very good. All right. Very good. Very good. Okay. 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 Iron 9. Sorry, fluorine 9. 1s2, 2s2, 2p5. So, which block? P block? P block means S plus P plus 10. Means 2 plus 5 plus 10. 17. Potassium. 1s2, 2s2, 2p6, 3s, 2, 3p6, 4s, 1. S block. S block means whatever is the number of electrons in S orbital, that will be group number 1. Iron 26, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So d orbital means d subshell it lies in the d block. D block means ns and n minus 1 d, that is 6 plus 2, that is equal to 8th group. 8th group. Silicon 14, 1s2, 2s2, 2p6, 3s2, 3p4, 2, 2, 4, 6, 10, 10 to 12, not 4, 2p2. Okay, that's it. So S plus P, because it is P block, so S plus P plus 10, that is equal to 14 group. That's it. Okay, that's it. Till here, if anybody has any doubt in any one of that question, if you have doubt, please ask. No doubt? Okay. Then there is some question for you. SB51, RH45 and SR, I think 39. Okay. Try to solve these. I think, please correct the data. It is 38. Okay, strontium 38. Ytterbium 39. Do this. Now it is okay. Okay, all 4 you have to do. Ytterbium, that is 39. Okay, do. Ytterbium 39. Antimony 15. SB is known as antimony. SB is known as, remember, SB is known as antimony. You have to stay away from this. It is not antimony. Okay, it is not anti-money, it is antimony only. Okay, it is against money. Antimony. RH is rhodium. Okay, rhodium 11. Very good. Antimony 15, rhodium 9. Let us see. Rhodium 8 also. Very good. Let us see. Strontium 2. Very good. Okay. Antimony, I think that is very easy. 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2, 3d10, 4p6, 5s2, 4d10 and 5p, I think that is 3, 2 to 4, 6, 10, 10, 12, 12, 6, 18, 20, 30, 36, 38, 48 and 3, 51. Yeah, that's it. So it is a p block element. See, outermost electron is going in p, so p block element, and for p, ns plus np plus 10, so 2 plus 3 plus 10, that is equal to 15. That's it. That's it. Rhodium 45, tell me, up to 2, 4, 4, 6, 10, 12, 12 and 6, 18, 20, 30, 36, 36 and 2, 38 and 38 and 7. So it will be up to here same, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, okay, 5s2 and 4d, what it will be? I think 7, 2 to 4, 6, 10, 12, 12, 6, 18, 20, 30, 36, 38, yeah, 45, okay. So it is what? Last is going in D, so ns and n minus 1 D, so that is 2 plus 7, that is equal to 9. So for rhodium group number is 9. Now let us move to strontium. Strontium is up to here only, okay, that is 1s2, 2s2, 2p. If you see up to here, it can be called krypton 36, okay. I am directly writing krypton 36 and then 5s2, that's it. Krypton 36, 5s2. Think about this. So it is again group number is 2 because S block kind of thing, and for this it will be krypton 36, 5s2 and then 4d1, that is the thing. So this is also 5s2, 5 plus 2 plus 1, that is group number 3, that is the thing, okay, that is the thing. 15, 9, 2, 3, 15, 9, 2, 3, very good, very good, 15, 9, 2, 3, very good, okay, very good, very good, that's it I think, okay. So this is what we have learned. We have learned about how to determine groups and periods, determination of period and determination of block we already know, okay. Determination of period we have learned, that is very easy. For all the given questions, I will be very thankful to you if you try and solve whichever questions are given for groups. Please try to find out their periods, and whichever questions are given for periods, please try to find out their groups. That would be very easy, that would be very helpful for you also, okay, and you will be also learning for that by that, okay. I think that's it. If anybody has any doubt, then you can ask, else you can go. That's it for today, okay. Bye everyone, that's it for today. If doubts are there, please ask. What are the best books to build my concept, sir? If you are thinking about inorganic chemistry, organic chemistry or physical, please specify, because there are different books. Okay guys, bye then everyone.